Welcome to the AI Research Roundup. I am Alex, and today we're looking at a paper from the Papers with Code trending list, published on the 16th of June, 2025. This paper introduces a new model that can simultaneously process and interact with text, images, and audio, and even provide live transcriptions as it listens. The paper is titled Stream-Omni, Simultaneous Multimodal Interactions with Large Language Vision Speech Model. So the big idea here is to build more flexible, large multimodal models, which are AIs that can understand different types of input, like text, images, and sound. The authors argue that current models often just lump all these inputs together and need massive amounts of data to figure out how they connect. Stream-Omni, however, takes a more purposeful approach. It aligns vision and speech to text differently, based on their relationship, using a new technique called a CTC-based layer dimension mapping for speech. As well, this leads to some really strong performance and a more seamless user experience. And for those of you who want to dive in and try this for yourselves, the code for this work is available on GitHub. The Stream-Omni repository has everything you'll need, including quick start guides and scripts to launch a web demo. Now, a key part of this is that CTC-based layer dimension mapping I mentioned earlier. CTC, or Connectionist Temporal Classification, is a method that helps align the audio stream with text, which is crucial for live transcription. The layer dimension mapping part is simply a clever way to reshape this speech information, so it fits perfectly with the main language model's layers. And this figure really helps visualize the difference. On the left, in diagram A, you see the old way, what's called sequence dimension concatenation. It basically just lines up the processed vision, speech, and text data and feeds it all into the model at once. But on the right, in diagram B, we see Stream-Omni's approach. Vision and text are still concatenated, but speech is mapped directly into the middle layers of the model. This allows it to simultaneously generate a live transcript from a process called automatic speech recognition and the model's final response. Alright, and this figure shows us the full Stream-Omni architecture in action, really detailing that process we just discussed. You can see raw speech coming in at the bottom, and it first hits a speech tokenizer, which is a component that breaks the continuous audio down into small, discrete digital units. These units then go to the bottom speech layers to create that initial text transcription. That text then feeds into the main large language model, alongside any visual information. Finally, the top speech layers uses special alignment-based fusion module to generate the spoken audio output, making sure it perfectly matches the model's text response. So what does this new architecture actually let the model do in practice? This case study gives us a great example. All the models are shown a floor plan and asked a complex question about a stairway. When using only the image and text, the competing Vita 1.5 model gives an incorrect answer, but when speech is added, it gives a different correct answer, showing a clear mismatch. This highlights a problem called modality interference. Stream-Omni, on the other hand, is consistent and correct in both cases, and even generates a final spoken response, demonstrating its more robust and seamless integration. And here's another great example of that robustness. In this case, the models see a picture of a stud finder. When asked via text what it does, everyone gets it right. But when the exact same question is spoken, the Vita 1.5 model gets confused and calls it a spirit level. Stream-Omni, on the other hand, stays perfectly consistent. And at the bottom, you can see the final result, a long, detailed 30-second spoken response, complete with the intermediate transcription. This really showcases that seamless, simultaneous interaction the authors were aiming for. As those examples show, Stream-Omni represents a really exciting step forward. By enabling simultaneous interaction across speech, vision, and text, it moves us closer to AI that we can converse with as naturally as we would with another person. This work on creating a unified streaming model is crucial for building the next generation of truly interactive and helpful AI assistants. That's all the time we have for this week's AI Research Roundup. Thanks for tuning in, and I'll see you next time.